Okay, so today we're going to do 7.5, properties of logarithms. But before we get into that, because it's been a while, I just want to go back to 7.3 and just remind ourselves, what is a logarithm? So a logarithm is an exponent. So just recall, for example, if I say, what is the log base 2 of 8, right? So I'm saying 2 to what power gives us 8? So x would be 3. So that means the log base 2 of 8 is 3. Okay, so logarithms are exponents. So in 7.3, we practiced rewriting logarithms into exponential form. We did exponential form into logarithmic form. And then we did some evaluating logarithms without without a calculator. Okay, so that's what we did. If you need to take a minute and go back and review that. Also, we did solving logarithmic equations. So again, we took many of these logarithms, rewrote them in exponential form, and then solved from there. We also did some equations where when we had the log on both sides, basically they canceled and then we solved. We just need to make sure that we checked our answers so that when we substitute it back in, it didn't give us a logarithm of a negative number. Okay. More of the same, changing to exponential form. Okay, so now we get into 7.5. So we have properties of logarithms, just like we have properties of exponents. So let's take a look at the first one. The first one is the product property. So for all positive numbers, m, n, and b, where b is not equal to 1, if we have log base b of m times m, that is equal to log base b of m plus log base b of n. Let me explain what that kind of looks like with exponents. So let's say I had x to the 5th power. I can divide that up into x to the 2nd power times x to the 3rd power, or vice versa. I can switch that around. Why? Because with exponents, what do we do with the 2 and the 3? We add them. So that's why we have here, right? If you add two exponents, right, that is the same as multiplying. Okay, so let's take a look at some example here with the logic here. Now, log base 2 of 8 times 4. So if we expand that into log base 2 of 8 plus log base 2 of 4, right? So let's see. Well, log base 2 of 8 would be 2 to what power, right? 2 to what power gives us, gives us 8. That would be 3. Plus 2 to what power gives us 4? That would be 2. And here, what is this? This is 32. So 2 to what power gives us 32? 5. So we get 5 on both sides, and that is how this property works. Okay, use properties of logarithms to simplify each of the following. Okay, so this is a 9 times y. So what we're going to do is we're going to expand that. We're going to make that log base 3 of 9 plus log base 3 of y. Okay, log base 3 of 9. So this is saying 3 to what power gives us 9? That's going to be 2. Plus, now log base 3 of y, we don't know what y is. So there's nothing else that we can do to simplify this. So we're just going to leave that. And we can't combine those. They're not like terms. Okay, next one. So I have log base 2 of 1/4 times 5. So again, I'm going to expand this. Log base 2 of 1/4 plus log base 2 of 5. Now, if you need to kind of do this over on the side, that's fine. So log base 2 of 1/4 right? So we're saying 2 to what power gives us 1/4? Well, 1/4 is 1 over 2 squared. So that would be a power of -2. So back here, this would be a -2 plus. Now, 2 to what power gives us 5? Nothing, right? Okay, it would be a decimal approximation, but because we're simplifying, meaning we only want to have, we don't want to be rounding anything. We don't want to have any decimals. So we're going to just leave the log base 2 of 5 because that is simplified. Next, we have the quotient property for logarithms. So if we have log base b of m over n, that changes to log base b of m minus log base b of n. This is, for example, let's say I had x to the 6 over x squared, right? So x to the 6 over x squared. So what do we do with the exponents? We subtract them to get x to the 4th. So same thing here. So when we see a quotient, we are going to subtract the exponents. Okay, so here we go. Log base 2 of 32 over a. So we are going to expand this to log base 2 of 32 minus log base 2 of a. Now, log base 2 of 32, we just did this recently. 2 to what power gives us 32? That's 5. Log base 2 of a, that's a variable. We can't simplify that, so we're just going to leave it. Okay, next one. Okay, so I have log base 5 of n minus log base 5 of 125. So again, whenever we have the variable, there's nothing we can do to simplify that, so I'm just going to leave log base 5 of n. However, the second part, log base 5 of 125. So 5 to what power gives us 125? 3. Okay, last one, the power property of logarithms. So if we have log base b of m to a power, what do? We multiply p to log base b of m. I'll give you an example. Let's say I had 4x to the 4th to the 3rd power. So I have, think of this, right? Log base b of m is an exponent and p is an exponent. So when we have a power raised to a power, we multiply the exponents. So basically, we take whatever the exponent is and multiply that. Okay, so use properties of logarithms, and log base 2 of a equals 10 and log base 2 of b equals 6 to simplify each of the following. Okay, so first thing I'm going to do, I am going to rewrite this as log base 2 of a to the 1/2 power. Remember, so square root is a 1/2 power, cube root would be 1/3. Okay, now what can we do to this? We can multiply that to the front. So I'm going to have 1/2 log base 2 of a. Now in the directions, we were given log base 2 of a is equal to 10. So I can actually substitute that in. So I'm going to have 1/2 times 10. So we get 5. Okay, next one. This one already has the exponent written here. So we're going to multiply that to the front. So that's going to be 3 log base 2 of b. In the directions, we were given log base 2 of b is equal to 6. So we're going to substitute that in. And 3 times 6 gives us 18. Okay, using properties of logarithms, we want to expand each expression. So let's start with, we're going to start with the division line. Okay, so remember, if you see these being divided, we're going to turn that into subtraction. So I'm going to first make this log base 8 of a squared times b. minus log base A of c to the third. Okay, next I'm going to work with this part. So I have an a squared times b. So I'm going to turn this portion into an addition. So I have log base 8 of a squared plus log base 8 of b minus log base 8 of c cubed. Okay, the last step I'm going to take care of, I'm going to move the exponents to the front. So I'm going to have 2 log base 8 of a plus log base 8 of b minus 3 log base 8 of c. Okay, so we're getting rid of all the exponents and changing everything into addition and subtraction. All right, let's look at the next one. So again, I'm going to start with the division part and turn that into subtraction. So I have log base 3 of x minus log base 3 of yz to the second power. Now the first part, the log base 3 of x, there's nothing I can do with that, so I'm going to leave that. However, I see I have an exponent here. Now I could distribute the exponent to y and z and make that y squared and z squared, but I actually would prefer to just leave the 2 in front of everything. So I'm going to put minus 2 log base 3 of yz. Now I want to take care of those 2. So those multiplied is going to turn into the addition. But I need to make sure I'm careful here because the 2 would need to get distributed. So I'm going to put this in parentheses. I'm going to make this log base 3 of y plus log base 3 of z. And so now I can distribute. So I have log base 3 of x minus 2 log base 3 of y minus 2 log base 3 of z. And that is in expanded form. Okay. All right, last example. Now we're going to go backwards. Okay, so we're going to take something in expanded form and we're going to change this into one single log. Okay, so what I'm going to do now is kind of backwards. So if you recall in the last ones, what was the last thing we did? We took, what was the first thing we did? We took care of the division and then we did the multiplication. Here, I want you to take care of the exponents first. So I'm going to move the 3 there and the 5 to that exponent. So it's going to be log base 2 of a to the third plus log base 2 of b minus log base 2 of c to the fifth. Okay. Now all the multiplications are going to turn into, all the additions are going to turn into multiplication. The subtractions are going to turn into division. So this is going to look like log base 2 of a cubed times b. And then I'll take care of now some of you might ask, can I combine these steps into one? Absolutely. I'm just trying to show you 2 steps at a time. So now I have log base 2 of a cubed b over c to the fifth. So that's all one logarithm. Okay, for b, we're going to do the same thing. So I'm going to move the 1/2. I'm going to move the 3. I'm going to move the 2. So I have log base 9 of x to the 1/2 minus log base 9 of y to the third minus log base 9 of z squared. Okay, if I start with these 2, so this is the subtraction is going to turn into division. So I'm going to have log base 9. I'm going to write that as square root of x over y cubed. Now I also want to divide by z squared. So again, some of you might ask, can I combine this all at once? So again, anything with a subtraction is going to turn into something in the denominator. So for the last step, I'm going to have log base 9 square root of x over, so it's going to be y cubed z squared. Okay. And that is how we write them in a single log.